Hi everyone, welcome to my channel. 2 questions. Would you need to do an exploratory data analysis? Would you want to do it on the cloud? If yes to both questions, this video is for you. I'm going to show you how to use Pandas-Profiling in Google Colab. Pandas-Profiling is a Python package for the automation of exploratory data analysis. Google Colab, on the other hand, is one of the most popular cloud environments for data science. By the end of this video, you will know exactly how to do EDA on the cloud. Without further ado, let's get into it. We first need to sign into our Google Colab account, like this. And then once we get into the Colab, we just click a new notebook. It would take probably a few seconds. To save your time, I have already prepared a notebook for this demo. The first thing we need to do is to install Pandas-Profiling. Note that Colab already has a pre-installed version, and this line of code allows us to see which version it has installed. Let's check it. Okay, as we can see, this is version 1.4.1, which is kind of old. We can Google the latest version by typing PYPI Pandas-Profiling in Google. Just enter. And then let's have a look at this. Here we go. The latest version is 3.2.0. So this is the version that we are going to install. Let's do it. It should be quick. Won't take too long. Okay, it roughly took about 1 minute. Another thing that we need to pay attention is the version of a Python package called markup save. Markup save is used for escaping characters in a program. What that means is that certain characters have certain functions, and by escaping those characters, their functions will not affect in a program. If that doesn't ring any bells, don't worry, this is not important. At this moment, we just need to make sure that the version we are using for markup save is 2.0.1 in order not to cause any error. Okay, let's check the version of markup save with this line of code. Unfortunately, this is not the version that we need. We have to install it ourselves. But this is no big deal. Let's do it. Hit install markup save 2.0.1. So that shouldn't take long. Okay. What this is saying is we need to restart the runtime. Okay, I will do it. Restart runtime. Yes. And then we can check the version again. I'm not going to override this one. We just do this. Okay, we're good to go. Now we have installed Pandas-Profiling. We can import it. Here, instead of loading the whole package, we just need the part that is called profile report. This is the functionality for generating those exploratory data analysis, which we will see in a moment. So far, we haven't talked about the dataset that we would use in this demo. Here, Scikit-Learn has provided users with cleaned and ready-made datasets. If Scikit-Learn is new to you, it is basically one of the machine learning packages for Python, and it has numerous tools for predictive data analysis. And here are some of the datasets prepared by Scikit-Learn, and we are going to use this California Housing Dataset for this demo. Now we know what we are importing. Let's run this. Here we are fetching the California Housing Dataset and then turn it into a data frame. And this data frame will be stored in a variable called df housing. And let's have a quick look at the first 10 rows of df housing. As we can see, this output looks very much like Microsoft Excel. And these are basically the column headers. So we have a median income, house age, average number of rooms, average number of bedrooms, population, average occupancy, latitude, longitude, and then median house value. These obviously can give us a sense of how the data looks like. However, if we want to have a comprehensive understanding of the whole dataset, we would need to do a proper exploratory data analysis. And this is exactly what Pandas-Profiling is really good at. And so here we can call the profile report function and then put our data inside it. It will do all the work for us and generate a report behind the scene. We then just need to load the report into this notebook. Here we go. I guess it will probably take about 1 minute. Great, it's awesome. Some people may not feel comfortable with reading the report directly from the notebook due to limited space, or there may be a need to share the report with other people. In either case, there's another option, which is to export the report into an HTML, and then we can open the report in a web browser. Let's run this. Okay, and this will be stored in the files folder within Google Colab, and then we can download it into our PC. Okay, it's done. And then we can open it in Chrome. Download. Let's open with Chrome. Here we go. There are basically 6 sections within the report. The first one is overview. It shows number of variables, which is number of columns, number of observations, which is number of rows, missing values, duplicate rows. All these are useful and high-level stuff. It even tells us how much space this dataset would occupy in memory. There are some interesting alerts. For example, it tells us which columns are highly correlated with each other. It also shows the columns that are highly skewed. All this information will be presented with more details in later sessions within the report. Let's continue with the variables session. This basically gives us all the information about the shape of the distribution of a column. We can have a look at the average number of bedrooms as an example. Here it shows the number of distinct values, missing values, mean, minimum, maximum, zeros, negatives. If we want more details, we can click the toggle details button here, and instantly it gives us the major percentiles, and it also gives us standard deviation, kurtosis, skewness, etc. Here skewness is quite high. If we have a look at the histogram, which is the shape of the distribution, and clearly this is not bell shape. If we still remember the alerts we have talked about earlier, here the average number of bedrooms is highlighted for its high skewness. Let's move on to the third session, which is interactions. This is basically a scatter plot between 2 columns. For example, here we are plotting the median income against median house value. As we can see, the majority of data falls into this range. The darker is the color, the more data points there are in the cell. We can argue this relationship is approximately linear. Let's switch to, say, house age. Apparently, the relationship between median income and house age is not linear. The majority of data falls into these cells, quite a bit down here and a bit up here as well. Feel free to explore other pairs of columns, and you may uncover some interesting or hidden patterns within your dataset. The next section is correlations, which essentially quantifies the strength of relationship between two columns. There are 4 metrics here, and we can get the definition of each one by clicking this Toggle Correlations Description button. The first one is Spearman's rule. It is a measure of monotonic relationship. Note that linear relationship implies monotonic, but monotonic is not necessarily linear. If that sounds abstract to you, let's have a look at a few examples. Here, the one on the left is linear and monotonic. The one in the middle is monotonic but not linear. The one on the right is not even monotonic. The measure of Spearman's rule can range between -1 and 1. For example here, if we look at the correlation between median income and median house value, the strength of the correlation is around 0.75, which indicates strong positive monotonic correlation. Next one is Pearson's R. It is a measure of linear relationship only, also ranging from -1 to 1. Okay, next one is Kendall's tau. This metric ignores the actual values in a column, but rather rank the values in each column for each row. It then measures whether the ranking in one column is correlated to the ranking in another column. Again, correlation can range from -1 to 1. For example, here we're looking at, again, the median income against median house value. The relationship is still positive, but the intensity has dropped compared to, say, Pearson's R, in which the color is darker here. The final metric is a new one, which was created in 2018 for measuring nonlinear relationship. The measure can range between 0 and 1. I'm not sure how to pronounce the name. Maybe Phik, Phik. Please comment below if you know the pronunciation. If you want to know more about this metric, you can refer to this paper, which is free to download. The paper was first submitted in November 2018. Okay, the 5th section is about missing values. Unfortunately, in our dataset, there's no missing value in each of the columns. And finally, we have a view of the first 10 rows in our dataset, which we have already seen earlier in our notebook. And here also we have the last 10 rows in the dataset. Now you have seen the whole EDA report generated by Pandas-Profiling. You have also seen how easy it is to leverage a cloud platform such as Colab for data analysis using Python. To be honest, this is the first YouTube video I've ever made in my life, and I hope you will find it useful. I will share all the Python code and related references in the area below. If you have any question or idea, feel free to leave a comment. Until next time, peace.